Hi folks, welcome to the Trig equations video series. This is a kind of teach yourself approach to trig equations, which are sometimes a bit of a stumbling block in grade 12 math. So when we say trig equations, we're talking about something like this: solving sine x equals a half. There's a trig function that's applied to our variable x. In this video, we'll be talking about the prerequisite skills before you can get around to solving those. And as I see it, it's these 5 things that are listed here. Know the table for special angles, which means sine 30, sine 45, or you might know the unit quarter circle or a hand trick or something equivalent. Know ASTC, which means in what quadrants in standard position we have positive sine, tangent, and cosine. Have to be able to sketch angles in standard position, which means we start from the positive x-axis. We need to be able to work in radians, and while it's true that we could solve equations in degrees, typically in higher mathematics we're working in radian measure. And finally, be able to find the trig value of any multiple of a special angle. And we'll look at what those special angles are right now. So when I say know the trig table, here's what I mean. Know the value of sine, cosine, and tangent for a whole bunch of angles. And specifically these ones: 0, 30, 45, 60, and 90. And there's a little trick that you can use that makes it super easy. So for sine, it's just root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. Those are the values. So if you can count from 0 to 4, you're all good. Now, some of these simplify. Root 0 over 2, well, that's just the number 0. Root 1 over 2, well, that's 1 over 2. Root 2 over 2 doesn't simplify, but it does have an alternate form as well. So we could call it root 2 over 2, or you could call it 1 over root 2. They mean the same thing. Root 3 over 2 doesn't simplify. Root 4 over 2, root 4 is just 2, so this is 2 divided by 2, or 1. Now the cosine line, well, it's just going to be the same as the sine, but backwards. So sine theta, backward. Okay, so that means starting at the 1, then root 3 over 2, then root 2 over 2, or 1 over root 2, 1/2, and 0. And on the next slide, we'll have this clearly typewritten out. Finally, we have the tangent line, so that's, or the row for tangent, sine over cosine. That's all we do here. So it'll be, for 0 degrees, 0 divided by 1. This 0 divided by this 1, which gives us 0. 1/2 divided by root 3 gives us either root 3 over 3, or you could write it as 1 over root 3. For 45, anything divided by itself is just 1. 60 is going to be root 3. And for 90, 1 divided by 0 is undefined. So really all you have to be able to do to generate that is be able to say the numbers 0, 1, 2, 3, 4. That'll give you the sine row, or the sine set of values. The cosine is just sine backward, and tangent is sine over cosine. Okay, the next thing we need to know is ASTC, which is really just asking us, where is each of these 3 ratios, sine, cosine, and tangent, positive? And here's how it works. If you have an angle that ends up in the first quadrant, then all your ratios are positive: sine, cosine, and tangent. If you have an angle that ends up in the second quadrant, only sine is positive. In the third quadrant, it's only going to be tangent. And in the fourth quadrant, it's only cosine. Okay, so that leads us to actually sketching some angles in standard position. And here's what angles in standard position means. They're angles that are measured counterclockwise from the positive x-axis. So if I wanted to, I don't know, sketch 30 degrees, well, that goes counterclockwise 30 degrees from the positive x-axis. That's what it looks like. And you can see right away that it ends up in the first quadrant. So that angle is going to have a positive sine, cosine, and tangent. They're all positive. Let's try another one. If I had 120, okay, I draw the axes, and I just go counterclockwise 120 degrees. That's about that far. Okay, and I'm in the second quadrant. So that tells us that sine will be positive, cosine and tangent will be negative. One thing that's worth mentioning here is that there's this extra little angle, the smallest possible angle that's made with the x-axis. That's called your reference angle, or theta ref. Always measured with the x-axis. And in this case, how big will that angle be? Well, we went 120 for the first little bit. It would be 180 to get through the whole line. So theta ref is 60. That's what's missing here. There's 60. This would be 120. And that's going to be helpful for us when we go to finding the sine and cosine of any angle. Let's do one last one. If I wanted to make negative 45 degrees in standard position, positive angles move counterclockwise. Negative angles are going to move clockwise. So all I do is I move clockwise 45 degrees. That's what an angle in standard position of negative 45 would look like. And obviously, its reference angle is going to be 45. That's the angle that it's making with the x-axis. Okay, to talk about radians, here's the basic conversion. 180 degrees is pi radians. It follows then that 90 degrees is pi over 2 radians. It's half of that. 60 degrees would be pi over 3 radians. 60 is 1/3 of 180. 45, that would be 1/4 of 180, so it's pi over 4 in radians. And 30 degrees is going to be 1/6 of 180, so it's pi over 6. And as we move forward, we want to be sort of bilingual between working in degrees and working in radians. I'm going to throw those values into my table. You might have noticed there was a little space up top. So 90 degrees, that's pi over 2. This was pi over 3. This is pi over 4. This is pi over 6. And 0 is just 0. So now we have most of the basic skills that we need. We also need to be able to find the value of sine, cosine, and tangent for any multiple of our special angles. So any multiple of 30, 45, 60, or 90. You can see I've got the table written out here. If it's not showing up well resolution-wise on your screen, feel free to download the notes. They're just in the video description. And there's a big one in there that you can take a look at. Okay, so example 1 says, use a sketch to determine the value of each trig ratio. So I'm just going to write over here ASTC, the all, sine, tangent, and cosine. And what does that tell you? It tells us which is positive. So if I'm in the second quadrant, sine's going to be positive. If I'm in the third quadrant, only tan's going to be positive, and so on. We're using a sketch to help us try and figure these out. So sine of 120. First thing I'm going to do is draw 120 degrees in standard position. The next piece of the puzzle is to find the reference angle. So if I have 120 degrees there, what's missing? 60 degrees. That's our reference angle. It's the angle with the x-axis, the smallest possible one. Okay, so now I know I'm really talking about a sine of 60 degrees, and I'm just going to mess with whether it's positive or negative. So we're talking about sine here. I'll go to my sine row, and the reference angle is 60. So sine and 60 Hey, it's root 3 over 2. Now check it out. That 120 degrees is in the second quadrant, which means that sine is positive. So my answer here will be positive. The sine of 120 is going to be a positive value. Let's try another one. Cos of 225. So again, I'll sketch it. How far is that? It's 180 and another 45. Okay, there's 225. And I have to figure out what this reference angle is. And I just said it as I was doing it. 180 and another 45. So that little angle there must be 45 degrees. Okay, here we're talking about cosine. So I go cosine of 45 degrees. That's root 2 over 2 or 1 over root 2. And my last action is to make sure that I correct it for whether it's positive or negative. So in this case, we ended up in the third quadrant. Tangent is positive there. The other two ratios, sine and cosine, are going to be negative. It's only tangent that's positive in the second, or in the third quadrant, rather. So this is going to be a negative value. That's why we need the ASTC. It tells us whether to make something positive or negative. Tan 150 looks like this. Let's think about theta ref. It's going to be 30 degrees in this case. So let's see what happens. Tan of 30 degrees, right here, it's root 3 over 3. Now let's see, what quadrant am I in? I'm in this one here, the second quadrant. Sine is positive, but tangent would be negative. In that quadrant, it's only sine that's positive. Okay, so the basic idea here is that we're going to sketch. I'll just write this down below. Sketch. Find theta ref. Use the table. And check ASTC for positive or negative. Let's try doing it in radians. So sine 2 pi over 3. I'm going to graph that or sketch it. 2 pi over 3. A pi over 3 is a 60, so this is really 2 60s. Or 120. Okay, which means that the missing angle, or the reference angle, will be 60 degrees, or pi over 3. Right, because 180 would have to be a full pi. 2 pi plus a pi over 3 would make a full pi. Okay, oh my gosh, this is one that we just did. We did it up above. But let's do it in radians using the table. Theta ref is pi over 3. So pi over 3, I'm looking at the sine. Great, it gives me root 3 over 2. And I'm in the second quadrant, which according to ASTC means I'm positive. So this should be the answer, root 3 over 2. And notice we got the same answer whether we did it in degrees or radians. So A and D were the same question. We'll try another couple in radians. Cos 3 pi over 2. So pi over 2 is 90 degrees. That's 1 pi over 2, 2 pi over 2s, 3 pi over 2. Hey, right there. Theta ref in this case is 90 degrees, or pi over 2. Okay, and I'm talking about cosine, so let's figure out what's going on. cosine of 90 degrees, or pi over 2. Gives us 0. And since it's 0, we don't need to worry about positive or negative. It's just 0. Okay, so I don't need to go to ASTC if it's going to be 0. I know that it's positive 0 or negative 0, no difference. Finally, 5 pi over 3. So pi over 3 is 60. This is like 5 60s, or 300 degrees. 90, 180, 270, 300 is just a little further. What's missing to complete the circle? 60 degrees, or pi over 3 radians. Okay, so we've got tan. The reference angle is pi over 3. Pi over 3 and tan. Gives us root 3. Okay, so the answer over here should be root 3. Now, just checking against ASTC. I'm ending up in the 4th quadrant. Only cosine is positive there, meaning that tangent must be negative. So our answer is negative root 3. To recap, to find the trig value for any multiple of our special angles, we're going to sketch, we're going to find theta ref, use the table, and then check for our positive or negative using ASTC. When we go to solve some equations, we're going to kind of reverse engineer this process. There's a worksheet that you can download from the notes and the description below, and there's also notes that you can download and go through the presentation with if you so desire. See you on the next one.